Hello, thank you for your interest in our video. We are representatives from VTEPS Incorporated, and we have a project to present for you today. My name is Will Vaughn. These are my colleagues George Broombaugh and Li Jing. So, in this presentation, we're going to be talking about something called a Rube Goldberg machine. And a lot of people aren't very familiar with that name, so we have a little video to give you a little bit more familiarity with it. So all of them start with an input. In this case, it's a phone vibrating to start the machine. The objective of the machine is to accomplish a very simple task in the most complex way possible. You have a bunch of different obstacles that are in sequential order, some simultaneous, and then in this case, the end goal was to boil a pot of water. So what we're proposing to do with the Rube Goldberg machine is teach physics concepts. Our goal is to bring a hands-on experience to the classroom, make it more fun, get students more engaged, and ultimately make a profit for our company.
In the beginning, each of us comes up one idea, and they are gravity, conservation of momentum, and centripetal acceleration. And for each idea, we comes up 3 obstacles. So we have 9 obstacles at the beginning, and we choose 3 better obstacles, and they are pulley for gravity, collision of different elements for conservation of momentum, and a loop for centripetal acceleration. We choose those 3 obstacles because we think those 3 obstacles can better demonstrate our idea. After we make sure the ideas, we make a chart for the whole project, and there are 8 tasks for this project, and we started at September 7th, and we will finish it on December 5th. And we can find that the line becomes shorter and shorter. We spent 20 days on the first 2 tasks because we think customer needs are very important for the whole project. And also we finish this project state by state because we need to finish one task, and then we can move to the next task. So in order to produce our production, we need to make sure the customer needs, and we interview 6 customers, and they include high school teacher, high school students, and homeschool teachers. And usually customers cannot express their needs clearly, so in the interview we need to make sure their customer needs. So we write down 8 sentences we think are important, and we need to change the customer statement to interpret needs. For example, let's look at 3. I don't want to be putting the set together for hours. It means the customers want to easy assembly.
So next in the process, we decided to choose 5 of the customer needs, and we placed them in our QFD chart on the left side, and then we added the 5 product specifications, like target specifications, that we decided would be most helpful in creating this product to be better and improve it. And in the middle of the chart, we added numbers that correlate between the product specifications and the customer needs to find out which one of the target specifications is the highest priority for the customer. In the second part of our product specifications, we use the bottom half of our QFD chart to analyze the correlation between the customer needs and the product specifications. So at the top part, it gave us a percentage of how important this specification was to the customer. And then underneath those importance percentages, we put in the units that we would use in order to measure these. So for the maximum weight, we would use pounds, and for the cost, we'd use dollars. And then underneath that, we added how hard it would be to implement this in the development process. For example, we chose quick construction time, and we'd say that's moderately difficult. So we put a 3 into the how hard category, that row. And then that, taking in all those things into account, the correlation, the percentage, the how hard, then it went into importance to the customer. So it ranks the importance from 1 to 5 of our customer specifications, and 1 came out to be our quick construction time. So in analyzing the economics of our product, we decided that our market would be an imperfect competition. So that means that there will be 2 break-even points, one early on and then 1 later on. So we don't want to manufacture too little, and we don't want to manufacture too many. The economies of scale, we decided that our product would fit into that, because the more that we were able to sell, the lower the price, or the lower we were able to build this product for, and the lower the price will be for it. And then in our graph here, when we were analyzing the economy, we decided that our product would be $45, and we'd start with a fixed cost of $10,000. And from there, we just analyzed it and saw how much our profit would be over time.
So in conclusion, we have a Rube Goldberg machine designed to teach physics concepts to homeschool students, public school students, and private students. We have a future plan to make the device modular and add on more concepts, not just gravity, conservation of momentum, and centrifugal acceleration, but teach more.